Alrighty, I forgot to do a live link for the class, but now it's here and I believe it. You should be able to see it if you go, I put it in Slack. And this time it'll be nice because there won't be a half hour of silence before if you do happen to go and look at them later. You don't have to fast forward that extra half hour where there's nothing said. Bonus. So I'm gonna go through sort of the basics of using the dictionaries that the book covered, and after we work through these, before we move on to the studio, I believe there are sort of two things that people have questions about with the crypto assignment. So I will cover those after these dictionaries. Because part of one of the examples I have in the dictionaries later, I believe will help make some more of the counting and assigning dictionaries a little bit easier. And if you have any questions while I'm doing anything, feel free to flail or ask questions or tell me I'm not being loud enough. All right, that should be a little better for volume. So dictionaries, as it mentioned, are essentially a key value store. What that means is you have, much like lists, you have a collection of something, and on a list, how you access them. So I'll actually add that in here, because that's, so if you have a list, and in your list you have some fruits. You access a list by giving it an integer value. That's how you get your values out of the list. With a dictionary, the difference is that you are able to get your values out by a name. So you no longer have to keep track of where things are at in your collection. You can just name them and go and get them later. So it's actually a lot more useful if you're wanting to get information back later or you're wanting some more complex structure to your information. So in this little play example here, the two things that I'm doing is associating the string value 1 to the integer 1, same 2 and vice versa, just sort of show how the two, you can assign any type of key that you want. A bit more realistic of an example that you might actually write is you could have fruit, and you could have apples, and you'd want to keep track of the fact that you have many apples and oranges, and you can have some pears too. And you can print out your fruit after you're done. And the nice thing there is that later, if I know I bought more apples, I can go and easily come in here and say, all right, I have 10 more apples. And then I can print my fruit. If you can write. Oh. So then here you can see that I added 10 more apples. This is an example of why I often use plus equal instead of the equals fruit at apples plus 10. Because as you start to have more and more variables, or you might have a more nested dictionary. So you could have a dictionary with dictionaries in it. So you could have a warehouse that has fruits and vegetables in it. And then those could have counts, which is actually the example later. But that way, you're not having to repeat yourself in your code with really long variable names over and over where you can likely what would happen. For me, a lot of the times I'd do something like this, and then it would break, and I would not catch necessarily. It's nice that Python will say, hey, you have a key error. This is another one of those sort of core errors in Python. The key error means you tried to access a value in a dictionary that did not exist. It mentions it specifically in the book. That if it is missing, it will raise an error. If you're unsure if a key exists, that's where you would do something along the lines of you'd go and say print this value. And it returns none instead of throwing an error if something does not exist. So in this case, I still have 10 of my apples. But up here, what using get does is it specifically says, all right, if it has it, try to return a value. And in that same sort of spirit, you can actually change it to default to a value. If you're going to use get to grab values out of your dictionary, if you have a default case when one doesn't exist, like say if you're trying to get a letter out of a dictionary that holds the count for letters that have been used, you could default it to 0 for whenever it does not exist, and then you know that you need to assign it at that point. There we go. The default return every time you call get is none if you've not provided your own overridden default for each time. But I am going to leave this as the plus equals because that is how it would generally be done, so you don't have to rewrite the same thing over and over. So this is a good example of a reason you would use a dictionary is you want to associate some sort of key, so in this case, apples to a value, which in our case is going to with dictionaries, you can combine them together. So in this example, what we're going to do is we're going to set up multiple levels to a house. There are 3 levels in this house: the basement, the ground level, and upstairs. And we're going to refer to the upper floors, which will be the ground level and the upstairs. So it's in view from the basement. The upper floors of a house would be your ground level and upstairs. So what we can see here, the smaller screen, I'm going to need to use that here. So I've mentioned using this before. It's called Pretty Print. And it does some work. Hold on, I do this later. Oh, that's my problem. It does not have the same signature as print. When I say signature, that means it does not take the same parameters inside of it. So print allows you to pass an arbitrary number of things to print. pretty print, which in Python it's shortened to pprint because apparently writing out pretty was too much work. Only accepts one value. But what it does here that is nice is, as you saw before when I printed it out, it was just a big long string of gobbledygook that's difficult to read. Whereas if you use pprint, it sort of gives you a nice format where you can see the key of each one of your dictionaries with its value right after it. As there are other things you can use in that module that will do some work to print out your output in a more readable manner. You can do things like change the indentation level, as well as tell it a slew of other things that you can do. I'm lazy, so I just used a base example there, but it can be useful locally when you're trying to print out what you're working on. So back to the dictionary example. So I create the upper floors by starting with upstairs, and I make a copy. And I use copy here, and this is a shallow copy, if you recall from last Monday when I was not here, but it was in what Tom covered. The shallow copy, so that when I go over here and I take my upper floors and I update them to give them the ground level floors, this goes and gives me upper level rooms that now have all the rooms that were in my ground floor and my upstairs. So upstairs had the master bedroom and the guest bath. Master bedroom, guest bath, and the ground level had the kitchen and the guest bedroom 1. So kitchen, guest bedroom 1, and you'll notice, oh, what away. It's not changing it here, but it will later in my larger example. Whenever you print out a dictionary, you are not guaranteed that the order these print in is the same every time. So don't depend on that. Don't depend on the order of the keys in your dictionary for anything you write in your programs, because they are not guaranteed to be the same. So if you end up getting a really big dictionary, that's where it happens more often that you don't end up with the same order of your keys when you print them out. What? Does it matter? So the question was, does the order matter? Generally, no. The order of your keys, if you go over your dictionary, do not matter. But there are times whenever, a lot of the times in data science, what people will do is go over very large data sets that have a bunch of keys with values. And if they're not being careful, they won't notice that when they go to take these values and store them off somewhere that's not in their current code, so they go to put them in a database somewhere or save it off to a file, they're doing it based on the position they're at and what they're iterating over instead of the key name. So they'll start assuming each time they run their program, that guest bath is the first one in the list. So then they go and store it. But then the next time the program runs, the first one could be kitchen. So if you don't always make sure that when you're going over a dictionary, which I do later below, but so if I wanted to say for, we'll call it room square feet in my entire house, I go over the items in there, want to print the room, and print the square feet of each room. So get my guest bedroom, 300 den. It's really easier to read like this. And these prints that I'm using without anything passed is just to make a space between them. So here, where I'm printing the key, which is the room, you can actually see it here. When I printed out the dictionary on its own, it showed den as the first item, and when I looped over it, it showed guest bedroom as the first item.
It's that pretty print's alphabetizing.
Oh, the statement was that Pretty Print is alphabetizing it, and that could be the case. In which case, that is nice that Pretty Print does alphabetize it, but when you're running over your code, you're not guaranteed that within the memory of the computer. So right here, that these are going to be in the same order every time you execute. So the other thing I did is I created the entire house out of the upper floors, and then I added the basement using the update. So what update does is it takes your current dictionary, which in this case was a copy of the upper floors, did the same thing up here, and it adds the new values to your dictionary, and then goes and prints out the upper floor here, upper floor and basement together. So the den is in the basement, as is the living room. Den and living room are in the basement with some square footage. And sort of wanted to reiterate how the dictionaries work, similar to the lists with shallow copies versus deep copies. So right here, everywhere that I'm doing this, I'm initially just doing a shallow copy. So when you call copy on a dictionary or on a list, when you use the built-in function. So right here, I have upstairs rooms. It is a dictionary, the master bedroom, and guest bath. When I do copy, it just copies shallow. And that first set of dictionary. So I get my upper floors, I add the ground level floors. And what I'm doing next is I'm saying, oh, those existing ground level rooms, I want to go and change, actually I'm gonna go and add a bathroom to the ground level. That is 200 square feet. So when this runs, I'm gonna do the same. I'm gonna end up adding this to all of them. Running it just on my screen, it was not as necessary each time. It is more necessary now. So the upper level rooms, which I went and added the ground level to. So upper level rooms have ground level and upstairs. So the ground level room has a bathroom of 200, which is what I added here. But if you'll notice, there is no bathroom in the upper level rooms because I made that update before I added the bathroom to the ground level. So any modifications to the most shallow level, so in this case, a shallow copy because they're all integers, it's going to be safe to use. And you'll end up with the ability to add more rooms to your house, and they don't affect the larger portions you built, which may or may not be what you want. In an actual house, if you went and added a bathroom to the ground level, your upper floor would also have that. So that's something to keep in mind if you go and combine dictionaries together, is how they actually get combined and how copy goes and creates a new one, and then update just goes and copies the values of what you pass into your existing dictionary. So in this case, is upper floors.
I have a question.
Yes.
What if the one that you pass in has the same key? What happens to the value?
So the question is, what happens to the value if you have the same key? So in this scenario, say you have big rooms, one's called living with 500, and we'll have another one, we'll have a kitchen that's 700, and then we'll have small rooms, and there'll be a small living room in these ones that has a 200. what happens if I do something like my rooms. So in this case, my rooms is 500, as you might expect, for the living room and the kitchen because it was a copy. So what happens when I do my rooms.update with small rooms? Is that it overrides your existing value for your key. So for instance, if you had a dictionary of A through Z and you were adding a value over and over, you could run update and it would automatically override that value. And that's what will happen each time you run update with the dictionary passed in to another dictionary, as it overrides it. So I don't know if we've used this word yet. The book refers to it as side effects when referring to functions, but in general, the concept is mutations. Mutation means that you're changing what you're passing in. So it's talking about side effects that you can have. So you pass a list into a function, then you can change its values and end up messing that list up with side effects. Same thing is possible with dictionaries and lists. Since they are both collections of items, you can end up with mutations. So the sort of key difference of how you will usually end up with a mutation when you're working with a dictionary or list, in this example, just because it's easier to write out a list, whenever you do what's called a deep copy, if you have A and B, and you do a deep copy of A, so A has the numbers 1 through 5. If you do a deep copy of A, you end up with B getting all new 1 through 5s. That's what a deep copy does. This is more in general of what deep and shallow copies do, because in Python, technically it won't matter before someone brings that up. But the shallow copy, what happens here is with if you have A 1 through 5, you do a shallow copy, and you just shallow copy what's in A. B at that point just references all the values that you have inside A. It is very relevant when working with dictionaries to keep that in mind. The difference between a deep and shallow copy, that is generally whenever you will accidentally create a mutation, is that you created a shallow copy when you meant to make a deep copy. And there are also times where you may want to create a shallow copy on purpose, be it for you don't want to take up as much space on the machine. You don't want to go and create a bunch of new lists or dictionaries so that you're not taking up as much hard disk space, or because you actually want those values to change between your different dictionaries and different lists. So there are different times where you actually do want the behavior, but if values are changing unexpectedly, a lot of the times what that means is you use a shallow copy when you meant to use a deep copy. Any other question?
So, is this similar to the cloning versus alias? Is this the same idea?
Yes, so the question was, is this similar to the cloning versus alias? And yes, the cloning and alias, so in this case, B is an alias for A, and in the deep copy case, B is a clone of A. But the reason for deep copy versus shallow copy, those terms specifically, is that an alias just references another value versus a clone. It's ambiguous on a clone if what you've cloned is a deep copy versus a shallow copy. So when you clone something, it is dependent on, a lot of the times, the language implementation or the specific library that you're using. You're not guaranteed that all of the So you can have nested dictionaries and nested lists. When you clone, you're not guaranteed that all of those nested values will be themselves clones. So in Python land, and I have an example further down here, it is where it uses deep copy versus copy. There's actually a module inside Python called copy that has a function in it called deep copy, which is why this is called deep, well, no, don't edit it. Which is why it's called deep copy, so it references that in the actual module in Python. So deep copy will give you the deep copy or clone as you would want. And regular copy is just a shallow copy every time, which is what is implemented when you do .copy on a dictionary or .copy on a list, is it does a shallow copy by default. So my next few examples are all built on the same thing, so you will see a lot of the same code repeated, and I'm doing that on purpose, so it'll be hopefully a little easier to follow along than my usual examples that are like 80 lines of code that I just babble through. So my hope is presenting the same code, I think about 6 times with a little bit added each time, will be a little better. Give me feedback one way or the other. If you like it, you can give it 2 thumbs up or down, or just 1, or no thumbs. So in this scenario, I wanted to give an example of, so a list can contain dictionaries. What I'm gonna have here is the number of fruits and number of vegetables. And I'll just have a list that contains 2 dictionaries in it. One being how many fruits I have, and the other one being how many vegetables I have. And then what I go and do is I happen to change just the number of fruits. So this dictionary up here, I'm not touching the list, I'm just changing the dictionary. But because I'm not doing any kind of copying, we end up with values being changed. So in here, what happened is I set up the list. So this is the same list both times. I'm just printing out my food amounts. And the number of fruits has apples. So if we notice, the vegetable counts stay the same because I did not modify them. But here in the number of fruits, I went and set apples. So this is how an example of accessing a dictionary and assigning it a new value. So you access it by the key, assign it a new value, and that went and updated the number of fruits that are within my list. So this causes a mutation inside of food amounts that you may or may not want. So in this case, I didn't actually want it because I wanted my food amounts as a snapshot in time. But now, at any point when number of fruits gets updated, my list is also updated. And that's not what I wanted for my food amounts. I wanted to know what they were right now. Be able to store that off. So what I would actually want to do in this case is I have my number of fruits and number of vegetables. And I'm going to put them in a food box. So I just called it food amounts before. But now what I'm doing is putting them into a dictionary instead of a list because I'm likely actually wanting to access them by their key values. So fruits, which are going to be the number of fruits, and vegetables, which is going to be the number of vegetables. And I'm doing a copy each time to ensure that I'm getting a new dictionary for my fruit and vegetables. And then I'm going and creating a second food box that is a copy of my first food box so I don't have to retype it over and over and over. So then I could make a loop here and go and make 300 food boxes that each start off. So say you were planning to sell a bunch of boxes of Girl Scout cookies to each one of the Girl Scout troops, you may sell the same box with the same quantities to each troop. So then you just want to create a copy of each one of those. So what I'm doing here is I'm just creating 2 food boxes that by default start with the same number of fruits and vegetables in them. So I set up the dictionaries, copy them out, get my second food box, which is a copy of the first, and then I go and change my number of fruits. And if you'll notice, the numbers of fruit and vegetables between the 2 boxes stayed the same. And that's because I actually went and copied these values. So they're in a new container, the same way they were before. They were in a list before, now they are inside a dictionary. But because I went and copied them, they no longer update the food box like they did before, because I made copies of them before I set it up. So to sort of keep this example going, what I'm doing now is, so I did the same thing before, but I'm showing specifically how this is a shallow copy. So if I go, and so I set these up the same, number of fruits and number of vegetables. The setup is going to be the same for all of these. I'm creating a food box, same as before, using copy. Creating a second food box, same as before, using copy. But in this example, what I'm going to do is inside food box 1, I'm going to go and update the apples to say there's 25 apples in food box 1. Because I decided that box, they ordered a few extra apples. They needed more. Because normally they would only start with 10 apples. So what happens when this goes and gets ran is I update it so it can be read. So apples should, in our ideal world, have been 10 for both, because all I did was go and update, not for both. Food box 1 should have 25, because that's what we set. But food box 2 also has 25. And the reason for that is because I've made a shallow copy of this food box. So even though I have a copy of these inside ones, the number of fruits and number of vegetables, whenever I make a copy of food box 1, that copy does not make a new copy of what is found here. So that ends up making a shallow copy. So that's something to keep in mind as you build up larger and larger structures to hold your information, is to make sure that you're not accidentally changing your values across them in ways you don't intend. So what likely I would want is deep copy. So there's a module in Python called copy. So you can say from copy import deep copy. And what this ends up going and doing, so in this example, I know I'm fine with my copies here. I want to go and get a deep copy of that food box before I go and modify it. What ends up getting printed out here is what we really wanted initially, which is my bad copy and paste skills. That always being 1. So now food box 2 has 10 apples like we wanted it to start off because of the use of deep copy. Most of the time, whenever you're using the dictionaries and you're passing it as a parameter value, so if you have a function that you're gonna pass them into, a lot of the time what you're wanting to do is deep copy that dictionary inside the function so you don't end up with a side effect that is unintended. Because as you write more and more code, you may end up with a much more deeply nested dictionary, and you can end up accidentally creating a lot of problems for yourself by updating values inside a function and not noticing that you've accidentally gone and changed. For in this case, you could end up changing someone's food order entirely from what they intended, like changing everyone's food order in your system to 25 instead of keeping them the same. It is pretty easy to do if you're not paying close attention to your deep copies versus shallow copies. Which is why I wanted to give an example here, specifically using deep copy that is built into Python. There are other ways syntactically in Python that you can achieve this. This one will work should work for Python 2.7, which is what Runestone uses underneath. So if you were to get a job somewhere or write Python code that required you to use an older version of Python, this will work here. That's why I didn't use, there's new syntax in Python 3.5 to accomplish this same deep copy. It's just that the syntax is a little bit confusing and you won't be able to run the same code in both places. So I try to give examples whenever possible that will work with all the Python, all the possible Pythons. So then my final example, feel free if you have questions. One, to give a more realistic example of where, well, at least where I would find value in using these sorts of things, which is if growing up, it would have been nice whenever we assigned chores to my siblings and myself, to which rooms we were going to do the chores in, and it didn't always feel equitable. Sometimes I felt like I was cleaning more than they were because the rooms were bigger. So this example is going to cover sort of actual ways that you might use lists and dictionaries together. Some of the work algorithmically that you'll need to do in the crypto assignment. It's one of the other reasons that I went for this example. So the same thing here. Oh, it doesn't all fit on one slide. That's all right. The chores, the people, and the rooms with size, this initial setup is the same on all the next code snippets that I'm going to go over. So I'm going to scroll right past them after this one. Keep in mind that I'm essentially saying, for sake of clean example, that the only chores that you can do in rooms are sweeping, vacuuming, dusting, and cleaning windows. I'm actually going to build on this example for Thursday as well, because you might be thinking that you don't sweep rooms with carpet. But keep those sort of things in the back of your mind for Thursday. For these examples, chores, those are the 4 chores you can do in any room, and they're going to be done in every room. People, I couldn't think of good names, so we just have kid 1, kid 2, adult 1, and adult 2, so they can have any familial relationship you want. And then the rooms that are cleaned are the rooms you see there. I think it's 9 rooms. Reason for that is so you can see more. And I sort of gave them arbitrary sizes. Those sizes, everything from here and above is copy pasted in all of them. So this first one, all that I'm doing is I'm creating rooms with chores. So I'm setting up a dictionary that has keys. And within those, the values of those keys are the chores you can do in each one of those rooms. So in the attic, what you do is you sweep, vacuum, dusting, you do the windows. Every one of the rooms in the house, those are the chores you can do in the room. And that's why sort of something that would be that is common to do if you are creating a dictionary of items and you know each one of the things is going to have some values, you would default them all to something that you need. So you could default them all to 0 if you were counting letters in words. So in this case, just sets up this dictionary with these lists for their values of what you can clean. So these are the rooms with the associated chores to them. The next thing that I'm doing is I'm setting the rooms So same thing here, initial setup, I have my rooms with chores. The next thing that I'm going to do is assign people to rooms that they're going to clean. I'm going to do this randomly. That's why up here I've imported choice from random so that it randomly chooses one of the people to go and assign some chores to. So the same sort of pattern. I'm starting off with an empty dictionary, has nothing in it. And then something I'm doing here, it's a little bit different than some of the things we have done in the past. These are actually this solution. So I'm taking the rooms to clean. I'm making a copy of the rooms you can clean. And if you'll notice, what happens inside this list is I'm actually removing each one of the rooms from the list of rooms to clean as I go and assign them to the person who's going to be cleaning it. That was actually some of the ways that people have solved some of the other studios throughout the class, is to modify what you're going over. So in this case, I'm just saying, while there are still rooms to clean, keep assigning them to a person. And this section here is also a common pattern when you're using dictionaries that don't have values. So what this while loop does here is I'm assigning rooms to people. First thing I do is I randomly choose a person in my people list. So up above, we have the kid, the 2 kids, and the 2 adults. I randomly choose one of those people. The next thing I do is I randomly choose one of the rooms that's still available. And then this check is very common when you are looping over data and using dictionaries, is to check if you've actually defined your key in your people with rooms. So my people with rooms starts off as an empty dictionary. So that person, by default, this first time, this is going to be false. So that person is not in the room. So one of the things that the book covered for dictionaries is you can check to see if you have a key already inside your dictionary. What this goes and does, this line says, if the person is already in the dictionary, I'm going to go and add them to the list. So that dot append is getting appended to a list. The else here says, oh, that person, I don't have that key set on my dictionary yet, so that person has not been assigned a room yet. So what I'm going to do is my people with rooms, so it was an empty dictionary to start off. The people with rooms, I'm going to say, at that person is assigned a list containing just that one room. Which is why each other time that I come through here, it's going to append another room to that list of the rooms the people are cleaning. And then I have, and so after I go and assign the room to a person, I remove that room from my list of rooms to clean. Otherwise, this would be an infinite loop because my rooms to clean would always be those 9 rooms. Then I would just keep looping forever because I'm not removing them. And that's why I made a copy, is so that I would not accidentally delete rooms out of the house. And then this last for loop here is strictly to ensure that for all of the people, so the 2 kids and 2 adults, that they actually there's a record of them getting assigned no rooms if they weren't assigned any rooms at all. So if it happened to work out that by random choice, the 2 adults and a kid got assigned rooms and the last kid was never assigned a room, my people with rooms dictionary would not have a value. So that's something else to keep in mind whenever you're assigning dictionaries values, is to always think about the case where it's possible that there was no value, but you want to know what that person was given. Let me see it. There we go. So I ran it twice. Since it's doing it randomly, the results are going to be different every time this runs. But this is a good example of adult 1 has no rooms to clean. And if I didn't have this extra loop here to go over and give it the empty list, there would be no record. Adult 1 wouldn't be in this dictionary, and we wouldn't know what rooms they were doing or not doing. The main reason for this is so that you are guaranteeing that you keep all values inside your dictionary. So the next 2 examples are more likely something you would be interested in, which is how much square footage is each person cleaning in the house. So if you wanted to make it equitable or pay people per square footage that they clean, so if you wanted to give allowance based on that, you go and multiply this value at the end to give them how much money you're going to give them for cleaning the rooms. This code's the same. I come through, assign all the rooms, have the people get all of their rooms, and then next what I do, and I've labeled this less efficient way to do it, and I said more CPU time. Don't necessarily worry about those terms, but I mentioned up above at the very beginning of this, some of the ways that people avoid having to write a lot of for loops is to store data inside dictionaries so that you're not having to nest a bunch of for loops. So in this case, what I'm doing in this for loop is I have an amount that is cleaned per person. So I go over each one of the people with rooms, which I've already ensured has every person in it. So that ends up being the person and the rooms they clean. So I know by initially what's going to happen is the amount cleaned per person is going to be 0. So I set that immediately. Amount cleaned by person, that person is equal to 0. They didn't clean anything. But then what I do after that is for each room in the rooms that are cleaned, I go and add that value from the rooms with size. So the first time I'm using this dictionary that's been here the whole time, which is up above, those rooms with size. So you can see how much each person cleans. So in this case, adult 2 cleaned nothing. Kid 1 cleaned 700 square feet, adult 1 cleaned 800, and kid 2 did a lot of work and cleaned the bulk of the home at 1,875 feet. But that can change each time you go through. Won't always work out with someone getting no rooms, but because there are only 9 rooms, it'll happen. Well, it is possible to happen. The key here, and the main thing I'm having to do, is have a for loop within another for loop. So say we were writing an application that was showing all of the rooms in all of our hotels. So you could have hundreds of hotels and then hundreds to thousands of rooms within those hotels. And if you're having to loop over all your hotels and then loop over every room in your hotels, the amount of time it's going to take for your program to run is going to be very long because you're having to wait for it to go at that point. 1 million or so times of checking the square footage of each room that is cleaned by whomever is cleaning the rooms in the hotels. So this next example moves this logic from here into the code that we had used before that was already going over every single room. So some people have asked some questions around algorithm analysis or sort of writing code that will perform better under different circumstances. This is an example of something that has a higher complexity for the machine to run, so it will keep running. It will take a lot more time for this to run. And this next example will take less time to run. So we set up the same thing, rooms with chores, people with chores, rooms to clean, and this is where it changes. So I'm taking the amount cleaned per person and doing the same initialization that I have done for the rooms up above and giving them a base value. So I'm saying, all right, I'm gonna go over each person, only gonna do that one time, and they're all gonna be set to 0. And then what I do in this while loop that I need to go over through anyway, so the while loop I was going through before, which I'm only going to go through the number of rooms that I need to clean. So what I go and add is within this, I go and say, all right, because I was assigning that room to the person at the time in here. So this is the while loop we've had in the last few examples where you take the room and assign it to the person. After I've gone and assigned that room, I go and increase the amount that person cleaned while I'm assigning them their rooms. So I'm putting that logic inside here at the cost of being able to read it and know exactly what's happening so that it will run faster. Because now I'm not having to go over, in this example above, I'm going over every person, and then I'm going over each one of their rooms. So I'm going over two lists at a time. So that creates, so if you think of that, the times table example that we did where you had 12 times 12, that ends up making you go over 144. So in that example, this is the same thing. I'm having to iterate over these, if this was the 12 times 12, 144 times. Whereas in this example here, if this were the 12 times 12, I'm only having to go over it 12 times because I'm not going over another data set inside of it. I'm just going over the room to clean one time, and I keep adding them as I go through. And then we end up with the same result. It's just as you get bigger data sets, this will be a more efficient way to do the same result in the same behavior. This next example, I'll just cover it really quickly. There's a statistics module in Python that you can use, as well as the max and min values. It's nice if you want to get an average, so you don't actually have to think about doing an average. You can just do from statistics import mean. You do have to be using Python 3.5 or above, so this won't work in Runestone. But it will work anywhere that's running Python 3.5 code. So if you need to take an average, you can use mean. So what I did here is I just took the output of one of my runs. So I had adult 1, adult 2, kid 1, kid 2, they all did different things. And I wanted to go and create lists of who had done the maximum amount of cleaning, the minimum amount of cleaning, and sort of the average amount. The reason that I'm using these lists and appending is it's possible that 2 people could have cleaned the same amount or not cleaned. So that way you're ensuring you always have, you have a list there because you have more than one of the same. This is mostly just an example I wanted to shows sort of processing that you're likely to do once you do have your data sets. This example of what has been cleaned. A lot of what people do on that further is sort of to get richer information would be to take different statistical analysis of that, which is actually what, where I work, a lot of what we do that is on invoice data. So we'll do this sort of stuff where we map invoices and then we sort of take a bunch of different averages to sort of figure out what we're going to do as a business. So in this cleaning example, what you could, and once you see this, you can say, well, adult 2 is cleaned too much. So next week, we're going to have adult 2 clean half as much, so they're not having to overwork themselves. So are there any questions on dictionaries before we move on to the studio for the evening?
What was the reasoning why you couldn't use that in Python 2?
Which one?
The statistic mean?
I believe statistics mean wasn't added until Python 3.5, but I could be wrong. We can look that up. Oh, new in version 3.4. So the reason you can't use the statistics module in older versions of Python is because it doesn't exist. So the question was, why wouldn't you be able to use this on Runestone? And that's because this package did not exist with the version of Python that Runestone uses. And there are a few other, if you remember your math classes or your statistics classes, there are some other nice functions built in that you can use. Median, you get mean, median, and mode, which is super exciting. Any other questions on the dictionaries or the example I've covered?
Can you use copy to combine two dictionaries?
So the question was, could I use copy to combine two dictionaries? And yes, but I would still end up doing something akin to what I've done here. So I've combined two dictionaries into a larger one using copy. If I wanted them to be at the same level, I would still end up calling update the same so right here I called update. What I would end up doing here with small rooms is just call small rooms.copy. I have my small rooms, a copy of small rooms used to combine two copies. But yes, you can use copy to create multiple dictionaries, but copy always creates a shallow copy of a dictionary, which you may or may not want, as I mentioned, the shallow versus deep copying. All right, I'll awkwardly stand here for a few more seconds before I go over to the studio. All right, we'll go over to the studio. That changed my URL. I am displeased. Does anyone currently have this pulled up? Well, I can't go through the code walkthrough because I don't have it, but
You're saying the studio or?
yeah, the studio. So the goal of the studio is to count there we go. It finally loaded. So we'll go through the walkthrough first. Yay! So this walkthrough, its main purpose is to give an idea of how you use a dictionary to continually store data, update it, change it, and return a different value. So what this is doing is having a gradebook. So a lot of teachers, instructors, professors will have gradebook programs, usually going from 0 to 4.0, as this shows. And the goal of this program is for the instructor to give you your grade and then give the credit hours for that course, which then the overall cumulative GPA that you'll have at that point is weighted. And this is done a lot on different financing systems or anywhere where you need to take true averages of data. You'll have different weights. And in this case, you're saying they got a 4, but it has 3 credit hours. So a 4.0 with 3 credit hours has a different impact on your overall grade than a 4.0 with 2 credit hours. Which this goes through and explains. Oh, I can't fit all the code in here. So what it does is initially you have no grades. So you just have no grades at all. This has a while true that it runs over and over and over. So it gets an input from you and it says is from 0 to 4, and it gets the credits and you tell it the number of credits. It makes a float out of your grade, an integer out of the credits that you pass, and makes that a dictionary. So you have a grade and credits. It's creating a list of dictionaries. A lot of maths. So it asks you at the end if you want to continue, which is a pretty common. So if you create a lot of what are called CLIs, which are command line interface programs, which are really fun to write, at least to me. And they are often fun to write as you first get used to programming because it gives you the easiest interaction mechanism to do something on the computer that you're not hard coding something in a file, running it, waiting, changing the values, doing it again. So by taking these inputs, it allows you to keep running the program over and over. Now, while true, this will run forever until it hits this break statement, which I don't believe has been covered. What break does is if you are in a block of code, so say you're in a function or a loop or an if statement, it basically just abandons what you're doing. So if you're inside of it, it's usually used within loops. So if you're in a while loop or a for loop and you use break, it will immediately stop executing that loop. And usually you won't use break because there are other ways to achieve that behavior in a more predictable way. A risk of using break in your code is that it may not be obvious when your loop's just going to stop working. So something with while true is dangerous because it may never stop executing. So there are ways to change this so that you don't have to use a break statement. What happens next is you have your total quality score, which is 0, and total credits, which is 0. The total quality score, that is what I was referring to as cumulative GPA before. And this comes over for each one of your grades and your grades. So grade info, your grades. Your grade info has a grade that you were given and the credits. It gets your total quality score, and then it gets your total credits, and your GPA is your total quality score over your total credits. So if you want to see this code execute in a way, oh, I should open that over there. Make sure I'm in the right spot. Yep. So what I will do here is this is the call it grades.py. This is the editor that I use. You are welcome to use any editor you want to use. Looks up the grades, has that while true and that break. What I would actually is use what's often called a sentinel value. Instead of using break, so that when it also makes it easier for someone who is reading your program. It's a lot easier to read while still getting grades than it is to just read while true, because then you have to read through the entire function for loop, your loop. You have to read through the whole thing to have any idea of whenever it's going to exit that loop. Whereas now you know, okay, anywhere I see still getting grades, changing values, that's how it's going to exit the loop. So this goes and runs all these. So now if I come back over, where I actually store my code, that last little bit I only had to do because I run multiple versions of Python on my machine. I use something that's called virtual environments. It makes it easier to run a lot of different versions. We can chat more about that later. Now if I go to the December folder that I have, I'm lazy at typing, so I usually tab complete. Both the Windows command line and the Mac command line have tab completion so that you don't have credits. We'll say that one had 10 credits. I got a 3.0 in it. I got a 4 in that. Interesting. Because it did not enter the character in, it actually just keeps looping because of that if statement in the code. So in this case, we'll say I got a 4 and a 2 credit class, and then I got, want to keep going, I got a 0 and a 4 credit class. So then it comes out and overall, I have the 2.375 GPA. The main thing that this is doing is having a command line program that goes and keeps using dictionaries, adding more values to your list. It's a new dictionary every time. And then finally at the end, it goes through and multiplies the values of your dictionary as it goes over them each time. So that same idea, oh, I should have made that easier to read. Oh, I'm sorry. In the future, remind me to change the color so that it's easier to read when presenting. I'm sorry. So the studio for today is to count the number of the number of times a character occurs in any given input string. So in this case, it will go through and count the number of periods, number of commas, the letter A, lower A, capital A, If you want to get bonus points, you can sort your output so that it's actually readable by humans and not just randomly organized. So the goal of tonight's studio is if you were given this big old block of text, you could tell the number of times each character occurs. And uppercase and lowercase separately do matter here. All right, I'll give a bit of time to work on this. And I'll walk around if you have any questions about this or the crypto assignment. Feel free to mention it. Given the amount of time we actually have left, I will get to go over some of the crypto stuff after we get through the studio.
So do you ever do financial calculations in your mind? Like adding, subtracting?
Yes, which is why we actually have a problem with floating point arithmetic in our Go libraries. And it's because we're not using a proper floating point library. So the reason we are okay is because we define the amounts, so we're not actually losing anything because we go and eventually, we'll never overdo. We'll always round down. All of our things round down. So what that usually means for the part that I work on, where we actually have to do ACH transactions, is we send out loans. So what that means is we end up having to have someone look at our UNP bank account that has all of our money that we lend out and have to end up adding like $2 to our available funds every month or two, which isn't great. That's a known. So what we should be doing and what is generally recommended is because as far as Western are, so we should be storing it really as an integer within our calculations going to decimal places. So keeping them as integers the whole way and basically dividing by 100. That's the standard way of doing it, so that you don't have to worry about a particular language messing it up. But that we don't do that largely. We have two separate teams, so we do analytics on data, and if we were to store the data as integers,
use.
Yeah.
And try to store it in ways that you can pull it up. A lot of people all basically kind of spreadsheet at it. So are you working on a financial app?
We're talking to ads. So they do platforms.
Yeah, I'm assuming. Well, they might use the decimal class. Because that's also, so specifically Python is what I've read. I don't get to use Python or try.
So what do you do mainly?
So we mainly use Go. I don't like how it's but I write it. But Go is pretty awesome. Because it is really just almost just like writing Python code. It's statically typed. Files down to know early on. But it has the same business that it's very one here, give it height, like a type password. You can't just reassign it. I know what I want to do.
Apparently that's is like Python shop.
Yeah, that's actually I found them interesting. Are they there's I think a trade bot located up Briarcliff.
Or not, fastest. 435.
Yeah. They usually do a lot more community things around Python, but they'll often what I find interesting is the way that they sponsor hackathons. Because they'll put really specific sponsorships trying to get people to basically try to write some financial algorithms without them necessarily connecting to that.
Oh, I see.
Because I was going to do a few hackathons and I realized I kept showing up like really different problems. It all seemed a lot like I'm just trying to get people to financial. You're just testing or testing the speed at which it's working.
Yeah.
The other thing that I think they've done for some of the trading things that I didn't see call the binding from Python. So I think they have a large the web.
Oh, yeah, I know.
All through, I think it's all just to get fast and trade. They both were Python shops. Financial technology starting.
Yeah.
And they kept showing up at multiple, basically doing the same things. They're trying to get people to write efficient algorithms for
So
solving
is that
problems.
still something they do?
I don't think they're as, I don't think they need people as much now as they did. And now, well, at least TradeBot, what they're doing is they're getting people to, they're like supplementing their developers to actual financial advisors. So they have both long and short term algorithms and they tweak them to it all the time. That is actually not a job I would want because you make a defect that's like $200 million for the loss.
Right.
Whereas my defects are easy for us to fix. Not easy to fix. Like, oh, we went and traded. Oh. Well, because there have been people let go for that.
Yeah.
Like, well, I don't know what you expect. I don't know how you can, until you have it on a real data set, which is going to be very difficult to do other than the actual NASDAQ exchange.
Right. Yeah. That's a good point. Right. Yeah. Why not? Otherwise, it becomes space. Look at something.
Got the question right.
Yeah.
Yes. Yeah, this
Oh, and it's, show you some of the ways I'm show you yeah, the chance one. Yeah, you have the I had the graph before. I think sort of take. Also, that's it. Think about making it. Yeah, that's right.
Yeah, so that's what I wanted to do. And or no, that's just the strap. Carousel. So you can do the, I just have to. I have, so. Yeah, they have it. Yeah. And
It's like the series highlight.
that shows you like what site style. Let's see, all right.
That's true.
Yeah, I recorded myself. That's my mouse. True. Yeah.
I still think
Come along.
So Space I am.
So that same box. Problem is that but actually, the second. Yeah. Yeah, right now, all my actual. So I got to figure out. That's fine. Oh. I know, I need to watch that. Just the name of the one. Server things. Yeah. Server, it's like trying to open up. But this says.
Well, no, but this,
Mine might just. Every type of sound like it's.
That may be the difference.
There's no I think it's actually. So that helps the server to tennis. Yeah. Yeah. So that's. That's a reminder. Of these devices. Telling it.
I mean, you take a look at one. The outfit. Sort of, yeah.
I have access to.
We can some of those sites. Oh, yeah.
That's a question. Yeah, that's power. Crossover. That's power. Yeah. It's cool. Yeah. You like this. You can get so what I did is so like one yeah, I mean, I have some on here that. Sort of just one month. So you have this thing. Adam Brothers or something that runs. That's where I use the this like and I was sending out to this
Well, yeah, but here. But then you install it, they would call their students. Try to get it. Yeah. Right. That's why it sounds like. Yeah, that's right.
I got this return.
Alrighty, we will go over the first counting example that I was given here. So what this one does is it is given a string, which I would actually, so in Python land and in any programming language, generally whenever writing code, I try to avoid any words that might conflict with something in that language. Python has a string module, so I would avoid calling a parameter string so that if I go and reuse this function somewhere else, I don't end up no longer being able to use the string module. So before this was called string. There's a string module in Python that you can use to do various, it's what has, what's that called? It's what has all the ASCII text and such in it. So, I want to talk through one of the reasons I would often modify someone's code. So also here, in Python, the general practice is to do what is called snake case, so that you write your variables and functions all lowercase with underscores separating words. Then I happen to like white space because I think it's easier to read what's going on. So this function is going to go and count the characters. You pass out a bunch of characters, it's going to count them all together. Your string is just a bunch of characters. So for each character in your list of characters, if that character is already in there, it's going to add 1 to the count. Otherwise, it's going to start that count off at 1. And then what this goes and does at the end is this is sort of something that you get if you use more advanced editor. It'll tell you things about what is happening. So what this line does on line 10 is it's calling sorted, which will order your dictionary automatically. So what I would normally do here to make this a little easier to read is call this sorted. Apparently the formatting is on. Yes. And then this return statement is actually unnecessary because the default in Python is always to return none in a function, which is okay here. There we go. Now I think it's all formatted correctly. So we go over the sorted characters, and then for each thing in our sorted characters, it goes and sorts them. Goes over each one, and it prints them because they are sorted. So over here, in the executed version of the code, I name this file counting. Folks will go and count them. There are 8 spaces. Ooh, it's not actually sorting them. So sorted is not sorting there. But to get the actual sentence we have.
I think that it is sorted, that is sorted as characters in capital.
Oh, you are correct. Why is this? Not letting me paste. There we go. So this is more what you may expect for the count of each one's there. This doesn't have a value if it does not exist. If you wanted it to always have a value, you could go in here and on your initial character dictionary, create them. Maybe I'll get lucky and someone did that. So someone asked if you exclude the string, on the input here, what would it do? In this case, it actually isn't going to do anything because the default return type for input is string. So if I come here, I end up with the same output because string is what gets returned from input. So unnecessary in this case to take your input and make it be a string. So Different editors give you different sorts of things. I'm using a plugin, VS Code, it's called Python. Makes it nice so that in this case, input, I just hover over it. It gives me the Python documentation on what input does. Same thing is true for print. Gives me the type signature there, so I can pass as many values as I want. I can say what separator I want, the ending character I want to use. You can actually change other behavior about how print works. But mainly what we'll do here is it'll say it prints out the values. And then it tells you what you can do with all your other parameters there. But that's where using different editors gives you sort of different advantages or disadvantages. Oh, the other example provided. Oh, I think they all have extra space here. Oh. Well, just so I can make sure I don't have to. Now if I come in here, this will be Studio. Now if I enter that text that we had before, we end up getting the same output because this is going over each one of the texts and then keeping track of the count, doing the same sorting. Now what is different here is instead of calling sorted on the dictionary, this is a little bit more explicit and it's using a function that exists, correctly called a method, on the dictionary. So what you get here down here at the bottom, we have all of your dictionary keys from the dictionary. So when you call .keys, it's going to return a list that has every key in your dictionary. The fact that this has dict keys and then has a list inside of it is an artifact of this being Python 3 and above. They changed, that's sort of one of the big differences between Python 2 and Python 3 is internally how it handles dictionaries as a structure for information. Because in Python 2, if you're curious, all you would have had is a list, and you would not have had a dict keys that is a list. For some optimization reasons inside of Python is a reason why they took the direction to make a change between the two versions. But the core of it is you have a dictionary called count that has all of your letters and the values for them. You can call .keys on that to get an iterable that has all of your keys in it. So what happens here is you sort all of your keys. And one of the advantages of doing it this way is you know it's sorting, you know what is getting sorted explicitly. Whereas when you call sorted only on the dictionary, you have to make an assumption about how it is sorting. Whereas sorted on keys, you know that it's returning a sorted version of the keys. That's one of the nice things about being able to call keys. So you can get those values. And that's where it is different, another option. List sort, source in place. If you did want to sort them, you could use the list sort instead of calling sorted. So does anyone have any questions on this one? Because for the next few minutes, I do want to cover a little bit of the cipher assignment. Specifically, what I'm referring to is the salad dressing cipher, because I can't pronounce the word that looks like vinaigrette, but is not. So if there are no questions here, we're going to talk about the salad dressing cipher. And the key piece that I want to mention, so sort of as a basis, to get an idea of how the Caesar cipher works, which the salad dressing cipher is a combination of Caesar ciphers together. So what happens here is you have the letter A, you're saying, I want to go down the alphabet, 13 more positions, and 13 down from A is N. That same thing is done here, so for A, B, C, D, that whole string is going to say for the first character, I'm moving down 13, I get N. For that second character, which is a B, I'm going to move 13 down, which is O. So it moves down each time that rotation amount that you've given. So you have a list where you've defined your 26 letters in your alphabet, if you did it with a list. But effectively, you can think of it, you have a list of 26 letters. You're going to keep going in that list in a circle. And further along in the alphabet, you can actually end up rotating back around. So like L, 13 goes to Y. If that had been a 15, it would have gone to A. Because at 15, at 14, it would hit Z for L, and at 15, it would skip from Z and go to A. So that's how the Caesar cipher works. The salad dressing cipher combines the Caesar cipher and another cipher on top of it. So the way that it works, you have your input text, same as what you had before. So you have your input words as you're going through. So it's a little bit easier to tell what's happening. Is you define what is going to be your rotation. So what was used for your rotation in the base Caesar cipher was the text itself. So your text defined the rotation on your wheel of letters that go from A to Z and just keep looping around no matter what number you get. So just think of it as a wheel. You keep going around and getting letters. Caesar cipher, you're using the text that you're encoding as the encoding value, meaning you're going 13 away from that text. What the salad dressing cipher introduces is it says instead of only using your character that you're wanting to encode, you're introducing another character, which in this case is set to use boom as your encryption key. So you'll have your encryption key, And that is what is used to determine your rotation. So it ends up being the rotation from your encryption key applied to your input string. So that's why when you say you have 14 is a rotation from H, you end up with V, and 14 is a rotation from E, you end up with S, is because that rotation is getting based on your cipher character, but you're rotating your other letter that far forward, which is why likely what you'd want to do when using this, if you were concerned about security with this algorithm, you would use a less readable key, so then it'd be a lot harder for someone to tell what's occurring. One of the other areas that there has been some undue stress for a lot of people is sort of looking at the whole problem too much at once. So try to ignore everything in this entire assignment and do just work through it, each little section at a time, slowly building on it. Even the areas where it says to put stuff in the encrypt file and then you eventually go and move it. Like, don't worry about what you're gonna do later. Just use the small building blocks initially. So even this little initials part where you go and do the initials of the name. Do that little bit to then be able to generate the assignment mentions here where you get the initials, the person puts it in, it'll print them out. Each one of these sections where it gives the notes, tips, and hints, it's specifically giving them there because you will need that idea for the more in-depth portion as you go, and it does a really good job of building on itself so that you initially just build out from your Caesar.py file. So you can import it, you can use it, and you're slowly adding to it as you go. Just make sure that as you work through the problem, you work through it as slowly as you can there. As you get more questions about the assignment, feel free to post them on not Vocarium, Piazza. If you have a specific question about why your code is working or not, send that as a message to your teaching fellow and myself on Piazza so you can get some direction there. If you just have a question in general about, oh, I'm not quite following what it wants me to do here whenever I go and make this a dynamic rotation so that the person can say, oh, I want it to rotate 10 or 7 or 3 anytime it goes in. Black, that's fine. But the goal would be all those types of questions could happen on Piazza, so it's easier to have a record of people's responses, which for some of the things has happened and for others has not, but it would be good to have a central spot for all the questions related to this cipher problem that is due somewhat soon. And then the last thing I wanted to mention for the night, hopefully I can find the link. I thought it was shared. If someone has the link for the Advent challenge, there we go. So I'll share this in our Slack channel as well as put it on my notes. One of the other instructors in St. Louis went and created an advent of code. So if you want more practice at writing some code, doing different things at home, the book doesn't quite have enough, you want to do more, this person was named Brian, who's an instructor in St. Louis at one of their 2 classes. He went and was writing out a bunch of examples of how with these different challenges and solving so sort of reading through and solving different specific challenges each day. It will be completely different. And likely you will write a program locally and run it, and then you will answer and know whether or not you're correct on this first one. You can kind of cheat because there's only 2 answers, but it's not as much fun if you don't solve the problem first and then know you're correct when you submit it. On the other ones, like you'll see on those conserving candles, you have to go and figure out how you can conserve the candles.
So where is that link here?
So I put the link in the Hello Casey Slack channel, and I'm also going to put it in my notes for class, which you'll see right here on. So normally I just link these in the assignment after each class. So if you want to go back and see the in class, it's there linked, which then we'll have everything we did in class as well. But that's all for tonight. Thanks for coming. We'll be back here on Thursday. Continue asking questions if you have any. If you have any feedback for how information is covered, feel free to get it. Oh, and if you could put your chairs back where you got them from or close to, that is greatly appreciated. Yes. Wait, today's December 5th. Oh, no, there's not a problem. Nor so the only reason I really don't do that is that's just a lot in one line for someone to read. So if someone were just glancing over this code, it may not be obvious that the keys they're going over are not actually what the iteration is. It's a mutated version, a changed version of that. So that's why we I would normally just create a temporary area. And that's usually just so it's easier for anyone to come in and read it. And I would do that. Anyone can do it. Some people do not. That's usually harder in general for a lot of people to work on that code base. If everyone brings a different sort of so normally,
But sometimes it is
really different things. Depending on the job that you have.
I've seen
So if you're someone who's switching between those 2 languages a lot,
and someone else who's only writing in that language, the person who's only writing in that language is going to write a lot of more concise statements because they're used to it. But then someone like me that might write multiple, I'll come to it and I won't be able to work through it as quickly. I'll have to pause and read it very carefully. Whereas if each one of these assignments and expressions for each one are online, it's a lot easier to do. Okay. They're sorting the dictionary and then they're going over it. So it makes it a lot easier to read. The main reason being a lot of people jump between multiple programming languages in a single multiple projects. Yes.
Same one.
Hello.
Do they know anything about Unit 2? People ask me about it.
I mean, other than little generic cover and maybe weapons. That's it.
They not specifically keeps asking if they have material ready, when they'll be out.
Materials will be ready.
So after they come back, they know what it is.
One of the reasons they had time. So
I keep telling them, don't know what's going to go on Thursday. I'm not going to be here. I'll be at a meeting at work, but I think that meeting too. So I wonder about. Well, there's another space here. But I don't know. Well, no, I mean, there's another space. So there's a. Are you talking about like the front? Well, if you go to the yeah, that's what you're talking about. Or. It is. I don't know. I was just throwing it out there because I had mentioned it. I was like, sure. But I don't know. But they still don't even know if they're going to have it here. That's just what they said today. They were sure. If it gets too complicated, we'll just head into this place. So, well, unfortunately, yes. See you next week.
Oh, Tina just showed me. She's the woman that's sort of in charge of the space.
Okay. You didn't have a small one.
Yes.
Oh. I did not turn the fans on tonight. I normally do.
But no one complained about it being too hot. So.
Exactly, like